solving systems of equations like you did on your quiz, but these won't be set up for you up front. What you'll have to do is read the word problem, figure out what the equations are, and then solve it. So we're going back to word problems here. I'll try to read them slow and really break down where I'm getting the equations from. The thing about word problems is, there's really infinitely many different kinds of word problems that are out there. I'm going to go over a few here. And as we go through these, what I want to focus on are, what to look for as far as, what are some common types of problems, even though the items might be different that are in the problem. Quite often, many of these word problems can be set up in the same way. So let's start with number one. It says Trevor bought 7 cookies from a bakery. Some of the cookies cost $3 each and the rest cost $4 each. If he paid a total of $23 for the cookies, how many of the $3 cookies did he buy? So when I approach a word problem like this, the first thing I want to do is identify what my variables are. Now before, we only had one variable with one equation. Here we're going to have 2 variables with 2 equations. So the 2 things that you're trying to find are the number of $4 cookies and the number of $3 cookies. This particular question is really just asking for the $3 cookies, but if you could find one, the other one's usually pretty easy to find. So you can use whatever letters you want. I'll use X and Y. I'll say X will be the number of $3 cookies, and Y will be the number of $4 cookies. When you're setting up these equations, oftentimes, and this is going to be one of those cases, not every time, but a lot of times with these system of equation word problems, there's going to be one equation that you write that has to do with how many objects there are, and then the second equation has to do with how much everything costs. So if Trevor bought 7 cookies, that's talking about how many there are. Okay, so we'll have one equation for how many, and then one equation for the total cost. Now, again, not every word problem will be like that, but you'll see this is going to be kind of a recurring theme here. So there are a total of 7 cookies, which means the number of $3 cookies plus the number of $4 cookies equals 7. Now, if this were a multiple choice item, honestly, you probably wouldn't even need to do the algebra, especially because these numbers are so small, you could kind of guess and check your way through it. I mean, there's only so many combinations that could add up to 7, right? Like 1 and 6, 2 and 5. You could probably just process of elimination your way through it, but I do want to show you how the algebra plays out. So one equation has to do with how many objects there are. The second equation is how much does it all cost. So if the X cookies are $3, we're going to charge $3 per X cookie and $4 per Y cookie. The total that Trevor paid for is $23. So that is going to be like a big part of the challenge here, is making sure that you're setting up those equations correctly. Sometimes the multiple choice items don't even have you solve it. They'll just say like which system could be used to set this up. So quite often you don't even have to work it out, but setting it up really is kind of the meat of the problem here. From there, we can just solve it like we did last time. Okay, we'll isolate one of the variables, plug it into the other equation, and just go through that normal solving process. So like if we want to solve, if the question here is asking how many of the $3 cookies did he buy, we're really looking for X. And so what we want to do is combine these equations in a way to where we just have one equation with X. In other words, we want to get rid of the Y. So what we want to do is try to solve for Y in one of the equations, and one of these will be a lot easier than the other to isolate Y, and then plug that expression into the other one. So if you look at these 2 equations and you think, okay, well, which one is going to be easier to isolate Y? Like, which one do you think? I think the top one or the bottom one will be easier to get Y by itself. Probably the top one. There's just less stuff going on, right? Like on the top one, we could just subtract X to move that over there, and then we've got the Y isolated. Down here, we'd have to subtract 3X, but then we'd have to divide by 4, That's going to generate a bunch of fractions, and we don't really want to have to deal with that. So definitely we want to use that top one. So we'll start with this, and we're just going to rearrange that equation. Okay, maybe I'll just write that down here. So if x plus y is 7, and I subtract x on both sides, now I've got y is 7 minus x. And so that is the expression that we can use to plug into the second equation. So we'll take that equation, that's 7 minus x, and substitute it in for y right here. Because that is what y is. So now I'm going to rewrite that second equation, but with that substitution in there. 3x plus 4 times, and instead of y, I'm going to write 7 minus x equals 23. And now we've got just one equation. We're solving for really, we don't care how many $4 cookies there are, but once we get one, it'll be pretty easy to figure out the other one. This is just strictly asking for the $3 cookies. So now we just need to solve for x. I'll go through this a little faster than I've had the past few days, just because I've been solving a lot of equations, and I think you guys are starting to figure out how to do that. So we'll first distribute the 4 to get 3x plus 28 minus 4x equals 23. Now we can combine like terms. So that's the 3x, and the minus 4x would be negative 1x. And if you're a little uneasy about there being a negative x, that's okay, it'll work out. So negative 1x plus 28 equals 23. Now I can subtract 28 from both sides. 23 minus 28. Now, feel free to use the calculator there. It's negative 5. And then finally, I need to get rid of that negative 1. That is the coefficient of x, so we'll divide both sides by negative 1, leaving me with x equals 5. So x represents the number of $3 cookies. The question is asking us how many $3 cookies are there. So there are 5. So there are 5 $3 cookies. How many $4 cookies are there then? If there's a total of 7,
2.
Yeah, 2. Yeah. So once you get one, getting the second one is usually pretty trivial. But yeah, it doesn't ask for both. Any questions about this one? All right. Number 2. We haven't done any geometry in here, so this is kind of getting a little ahead of ourselves, but I think we can still handle this one because it doesn't really require that you really know any formulas except for maybe perimeter. So it says the perimeter of a rectangle is 38 centimeters. So as far as perimeter of a rectangle is concerned, if you have a rectangle, the perimeter is the distance around it. So if I call like my horizontal x, or actually maybe we'll call it the length, L for length, W for width, the perimeter is all of the side lengths added up. It's the distance around the shape. So there's 2 W's, there's 2 L's. Perimeter is, well, just that, 2W plus 2L. Now in this case it says the perimeter is 38. So that's where our first equation is going to come from. 38 is 2W plus 2L. The next statement says the length of the rectangle is, okay, so the length of the rectangle, that's my L, is means equals. So I'm going to start with the length of the rectangle is 4 more than twice the width. So twice the width plus 4. And you can write it as 4 plus 2w. That works too. So there's our system. This question is actually asking for both, where w is the width and l is the length. One of these equations already has a variable isolated. Right, we see L is 2w plus 4. So we're going to take that expression and substitute it into L in the other equation. And then we'll have something that we can solve at least for one of the variables, and then we can go back and find the other. So we should have 38 equals 2w plus 2 times 2w plus 4. First thing that we need to do when we solve this is use the distributive property. 2 times 2w, 2 times 4. So 38 equals 2w plus 4w plus 8. Then I can combine my like terms. 2w plus 4w is 6w. Now I've got a nice little two-step equation, which I think all of y'all know how to solve these at this point. Subtract 8 from both sides and then divide by 6. So we'll start with the subtract 8. Giving me 30 equals 6w. And then I'm going to run out of room, but we're going to divide both sides by 6. And that's going to give me 5 equals w. So the width is 5. But this is asking for both dimensions. So we also have to find the length. So that's where we'll use the other equation. We're going to take this 5, which is w, and substitute it into w in the other equation. So the length is 2 times 5 plus 4. You don't even really need to do any algebraic manipulation here. You just type that in your calculator. 10 and 4 make 14. Okay, so the width is 5 centimeters and the length is 14 centimeters. Now again, if this were a multiple choice item, and on the TSI test, all the questions are multiple choice. Okay, definitely want to encourage you to use the fact that it's multiple choice to your advantage. As we go through these lessons, I like to take away the multiple choice so we can focus on the algebra. But when we get a little closer to actually taking the test, we'll talk like test taking strategies to where if you don't remember the algebra, you can still get it right. If you remember to like plug in numbers, and there's quite a few little tricks you can do. But yeah, definitely want to make sure that you know how to do it sort of quote unquote the right way. Yeah, any questions on this one? We'll also have a full unit dedicated to geometry. So if you didn't remember that whole thing about perimeter, we'll definitely come back to that. All right, number 3, it says the sum of two numbers is 4. Okay, so this is going back to sort of those key words. If I have the sum of two numbers, that means if you add them together, you get 4. So maybe I'll call the first one x is the first number, and the second number y. I thought about doing like f and s, but my s's oftentimes look like 5 just because just write kind of sloppy. I want to avoid that mistake. Okay, so the sum of two numbers is 4. So x plus y is 4. It says the second number is 1 more than twice the first number. So the second number being y is, so y equals 1 more than twice the first number. So twice the first number plus 1. Now, these numbers are pretty small, so again, you could probably just like figure it out by just kind of guessing and checking. Like if the two numbers have to add up to 4, there's only so many options. Yeah, but we'll go through the algebra anyway. So we want to find the two numbers. I've already got y isolated in one of these, so I'm going to substitute that in for y, just like we did today and last time. So I've got x plus 2x plus 1 equals 4. X and 2x make 3x. Now I've got a nice little two-step equation. So I'm going to subtract 1 from both sides to get 3x equals 3, and then finally divide both sides by 3. So the first number is 1, and if they add up to 4, what does the other one have to be? 3. So the two numbers are 1 and 3. And that second number is 1 more than twice the first number, because twice 1 is 2, and then add 1 more makes it 3. Not a bad idea to go back and just like check and make sure those two numbers actually work. All right, I've got one more problem for you before you start working on your own. This is going to be kind of similar to the first problem, where we have one equation that is talking about like how many things there are, and the other equation is talking about like how much it all costs, the total cost. So let's go through this. It says each family in a neighborhood is contributing $20 worth of food to the neighborhood picnic. The Hardin family is bringing 12 packages of buns, some hamburger and some hot dog. The hamburger buns cost $2 per package, and the hot dog buns cost $1.50 per package. How many of each bun did they buy? So we need to figure out the number of, not really the number of buns, but the number of packages, right? So, well, they both start with H. I guess I could do B and D for burgers and dogs, I guess. You could do X and Y. The letter itself doesn't really matter, but I'll let B be the number of burger packages, I guess. And D be the number of dog packages. Hot dog. We're not bringing dogs. All right, so let's think about the two equations. This is going to fall into the same kind of category as that first one, where we have one equation talking about how many, and the other one's talking about the total cost. So if you're ever like kind of confused on how to set these equations up, that's going to be a pretty frequent thing to come up as far as how you set these up. So you can always try to fall back on that if the context makes sense there. All right, so the Hardin family is bringing 12 packages of buns total. Some burgers, some dogs. So the total, as far as like how many, is the number of burger packages, the number of dog packages should equal 12. It's a total number. And then as far as the cost, the burger packages are $2, so 2B plus $1.50. And you could put 1.50. You don't really need the 0 there. And the total here is $20. And so now we're just going to go through those basic same steps that we did on the first one. So first, I do need to isolate one of my variables, although just like with the first one, this equation talking about how many there are, it's going to be a lot easier to isolate a variable. And here, it doesn't really matter like whether you do B or D, because you need both of them anyway. So we'll just pick one. How about, I don't know, how about we do B? So if B plus D is 12, that means that B equals 12 minus D. All right, and that's an expression that I can use to substitute into the other one. Come on. There we go. Okay, so I'm going to take this 12 minus D and rewrite that second equation, but I'm going to replace the B with 12 minus D. Okay, so I've got 2 times 12 minus d plus 1.5d equals 20. Need to use the distributive property. Which will give me 24 minus 2d plus 1.5d equals 20. Then I can combine like terms, which are going to be the negative 2d plus 1.5d. Now we're doing decimals and negatives, so definitely just like have that calculator ready to do that kind of arithmetic, just so that you can avoid that mistake. I hate for you to do all the algebra correctly and then you just a little arithmetic error somewhere that throws the whole thing off. So don't be scared about using that calculator as much as possible. All right, so negative 2 plus 1.5 will be negative 0.5. So 24 minus 0.5d equals 20. Then we can subtract 24 on both sides. So I have negative 0.5d equals negative 4. So 20 minus 24 is going to be negative 4. And then finally, I need to divide both sides by negative 0.5. Again, something you should just put in the calculator. Don't try to do that by hand. All right, anybody happen to type it in already? What does that come out to be? 8? All right, so we got 8 packages of hot dog buns, and if there's a total of 12, how many hamburger buns do they have to be? Yeah, 4, because 4 and 8 make 12. So yeah, usually that second variable is like pretty easy to find once you get the first one. So we've got 8 packages of hot dog buns and 4 packages of hamburger buns. Any questions?